This is another video lecture tutorial. The topic of this tutorial is a stoichiometry problem, which is limiting reagent, which is also called limiting reactant. And also it has a question about percent yield in the same problem. The calculation I'll be working out for you is found on page 6 of your homework packet for Unit 9. The question says, if 44 grams of sodium reacts with 10 liters of chlorine gas at STP, how many grams of sodium chloride could be potentially formed? So I've already written out for you the balanced chemical equation where we're reacting sodium with chlorine gas to produce sodium chloride. And the question tells me that I have 44.0 grams of sodium and 10 liters of chlorine gas. And the question is asking what would be the amount of sodium chloride formed if I have these two amounts of the reactants. So this is a typical limiting reactant problem where I have two different amounts of my two reactants. And in limiting reactant problems, one of them are of an amount that I will run out of it first. That would be my limiting reactant. The other then will be in excess, meaning there'll be some left over. So you have to do the calculation of amount of product formed two separate times. One basing it on sodium and one basing it on chlorine. And then from those two calculations, we can figure out which one is the limiting reactant. So first I'm going to do it with chlorine. I have 10 liters of chlorine. So in the first step, I need to convert that to moles. And the equivalent that's true in order to do this is to remember that 1 mole of any gas at STP occupies a space of 22.4 liters. So that's the conversion number that I'm using here to convert chlorine gas to the amount of moles that would be. Then in my next step, I'll be doing the mole ratio that we've been learning. Chlorine is the substance that I'm starting off with, so that goes in the denominator. And the substance that I'm interested in finding information about is the product sodium chloride. The ratio comes from using the coefficients of these two substances in the balanced equation. There's a 1 for chlorine and a 2 for sodium chloride. So there's a 2-to-1 ratio in terms of moles going from chlorine to sodium chloride. Then in my last step, I'm calculating how many grams of sodium chloride that would be. So sodium chloride goes in the denominator, and I have moles of sodium chloride, and I want to convert that to grams. .44 grams is the molar mass of sodium chloride. Calculating that from the masses of on the periodic table of sodium and chlorine. When you calculate this answer, you would get 52.2 grams of sodium chloride. So I'm done with that step. The next thing is now I need to see how much product I would get if I evaluate having 44 grams of sodium. In this case, I'm not using the 22.4 liters because I'm dealing with grams in this case. So I'm using the molar mass of sodium in the denominator, and that way I'm changing from grams of sodium to moles of sodium. Then in my next step, I'm doing my mole ratio. Sodium is the substance that I've been given information about, so that goes in the denominator, right? Whatever's up here goes here. And again, I'm interested in finding about sodium chloride. The relationship in terms of moles, looking at the balanced equation, is a 2 to 2 ratio. Then in my last step, I'm converting moles of sodium chloride to grams of sodium chloride, just as in the example above it. In this case, the answer I get is 112 grams of sodium chloride. So my calculations show that if I just look at the 10 liters of chlorine, I could only produce 52.2 grams of sodium chloride. If I look at sodium, I could produce 112 grams of sodium chloride. So I'm limited by the smaller number. This is the amount of sodium chloride I could produce. That means sodium chloride is present in excess. There's extra. So chlorine is my limiting reagent, and the one in excess is sodium. Then the final step here takes it one question further. 48.6 grams of sodium chloride are actually formed when the reaction is done in lab. What is the percent yield of this reaction? So I've been talking about recently how we don't always have a perfect 100% yield in chemistry, and certainly most of the time we don't have 100% yield. So we need to use the formula for percent yield. So my actual yield is what was really obtained during an experiment, and my theoretical yield is what I could obtain mathematically. And then we would multiply that times 100 in order to get a percent as an answer. So the question is saying that in the lab only 48.6 grams was obtained. We just calculated above that based on the limiting reactant, 52.2 grams of sodium chloride is theoretically what I would have produced for 100%. And dividing these two numbers, multiplying times 100, I would get as an answer 93.1 percent yield. So this is the answer to your percent yield based on your limiting reactant of sodium chloride. That's the end of this video tutorial. We've reviewed how to calculate limiting reagent and percent yield.